Okay, so today we're talking about slope. All slope is the rate of change. Think about things changing. Think about a graph. If you think about a graph, most graphs you think about look like this, or maybe they have some curve to it, or maybe they're decreasing. So all the slope is how those lines on the graph are changing and what is the rate that they're changing. So what axis is dependent? Well, my y-axis is going to be dependent and my x-axis is going to be independent. X, or my horizontal axis, is going to determine the change in my vertical axis, my y. So we already saw some types of slopes before in our graphing labs and things that we've looked at this year. We have 4 types of slopes. My first slope is a positive slope. My graph is increasing, so the slope is positive. Well, then if I have a positive, I also have a negative. As x increases, y decreases. Well, then I have 2 kind of special cases down here. If I think about this line, is that positive or negative? Well, you could say is x increases, y increases, but x really isn't increasing. This is actually an undefined slope. It's undefined because I can't walk it. Think about walking your slopes. In this one, I'd be walking uphill. In my second one, I'd be walking downhill. Well, in my third one, I can't really walk that unless I'm Spider-Man. It's undefined. That's an F right there. Then number 4, this is actually a slope of 0. This is a flat surface. Slope of 0. I'm not increasing or decreasing. I'm just walking in a flat old line. So this is the formula we use to find slope. This is the formula we use to calculate it. It's the change in y's over my change of x's. Slope we say is rise over run. I have to get out of bed first before I can move. So if we have 2 points, like our example below, this is point 1 and this is point 2. So if my ordered pairs are x comma y, for point 1, this is x1 and this is y1. For my second point, this is x2 because it's the x in my second point, and this is y2. So if I want to find just the slope between these 2 lines, I say that slope equals m. That's another letter we use for slope. So m equals y2 minus y1 over x2 minus x1. Well, y2 is 3, so 3 minus y1, which is 1, divided by x2, which is 4, minus negative 1, because x1 is negative 1. How I got all of these pieces are from these, bless you, from these 2 points. This is point 1, this is point 2, and x comes before y. Well, 3 minus 1 is 2. 4 minus a negative 1 is 4 plus 1. So my slope is 2 over 5. And that's it. That's your slope. We want to leave it as a fraction. And what this means is on my graph, to get from one point to the next, I rise 2 and I run 5. We'll start graphing lines next class or the next video, But that's all slope means. Let's try a couple more. So m equals y2 minus y1 over x2 minus x1. Well, if this is point 1 and this is point 2, negative 1 is x1, 5 is y1, 4 is x2, 2 is y2. So when I plug those pieces into my puzzle, I get 2 minus 5 over 4 minus negative 1. Well, 2 minus 5 gives me negative 3. 4 minus negative 1 is 4 plus 1, which gives me 5. Can I simplify negative 3 over 5? If I do negative 3 divided by 5, math, enter, it gives me this fraction back. This fraction is my slope, meaning I go down 3 and then to the right 5. Let's look at number 2. This is point 1. This is point 2. This is x1, y1, x2, y2. So slope, or m, equals y2, so negative 3, minus y1, which is 4, divided by negative 2 minus x1, which is 5. Well, negative 3 take away 4 is negative 7 over negative 2 take away 5 is negative 7. What's negative 7 divided by negative 7? Isn't that just 1 over 1? Or 1? Well, I'm going to leave my slope like a fraction, and what this means is as I go up 1, I go to the right 1. I rise 1, I run 1. I rise 1, I run 1. So sometimes we're going to have to find the slope from a graph. So this is my x and this is my y-axis. Well, we said that x is when I run, because I run left to right, and then y is my rise, because I rise up and down. So my question is, do I rise or run first? Well, slope says that I rise over my run. So if I start at this point, 0, 1, how much do I rise to get to the x coordinate? If I look at this point, how much do I rise to get to where I can get to that point by running? Well, I rise 1, 2, 3 places, 3 units. Well, then how much do I run? I run 1, 2 units. So my slope, my rise over my run, is 3 over 2. I can't simplify that fraction anymore, so my slope is 3 over 2. Let's try a couple more. If I start at this bottom point of negative 3, 0, and I'm trying to get to my other point of negative 2, 5, well, I have to rise over my run. That's what my slope equals. So I rise 1, 2, 3, 4, 5, and I run 1. I'm going to leave my slope this fraction 5 over 1. I'm not going to make it 5 quite yet. So my slope is 5 over 1. Lastly, let me try this point. So I started this guy right here. My slope is rise over run. Well, to get from negative 3, 1 to negative 1, 0, do I rise or do I kind of fall? I actually have to go down 1 unit, so my rise is going to be negative 1. And then I run 2 spaces. It's okay to have a negative slope. My slope for this graph is -1/2, meaning I go down 1 to the right 2. So this is finding the slope from the equation and from a graph. Here's a couple more that you can try. Good luck!